Good evening, everyone. So I'm Prashodan Padmanathan. So today is for my assignment for the quality assurance and testing. So that I have chosen two topics, which is principle and types of testing. So we'll go to the next slide, and so we'll see. So what is software testing? Software testing is far more than running a program and seeing if it cries. It is structured, principle, discipline, and the ISTQB's 7 principles give us the framework to do it right. So we can able to see there is a verification and there is a validation and there's a quality and there's a process. So we can able to go to the next slide. So we will see one by one what are the principles. The principle for the number one principle, the testing shows the presence of defects. What we are trying to mention here, testing proves bugs exist. It can never prove they don't. So for an example, so the payment system passes every QA test. On a launch day, 5,000 concurrent uses trigger a race condition causing duplicate charges. The defects were always there. The test just never found them. Passing test is not equal to bug-free software. A good tester tries to break things, not confirm their work. Zero failures found is not zero failures existing. Risk-based testing focuses on what matters most. Always set honest expectation with stakeholders. So we'll go to the next slide. So the second principle, exhaustive test is impossible. You can't test everything, so test the right things. We cannot test everything because there's a lot of test cases. We cannot test everything. So we have to choose the right one, which is important. For an example, a single 10 characters text fields has billions of possible inputs. Structured technique let a small number of carefully chosen tests cover what actually matters. So we will able to see this input combination grows exponentially for any real system. Equivalence partitioning, test one value per input classes. Boundary value analysis, defects cluster at the edges. Risk-based testing, focus on the highest impact areas first. Smart design, brute force coverage. So we'll go to the next principle, but we have to see is early testing. So early testing means find it early and fix it clearly. So for an example, a tester spots an ambiguous payment file field, recommend during review. Fixing it takes 2 hours. Missing it until post coding would have taken days to unwind and cross the code base. So what we can able to see is defects found late cost dramatically more to fix. IBM research 10x cheaper to fix design versus in testing. So test review requirements before code is written. Test-driven development. Write the test before the code. CI or CD. Pipeline gives early feedback. So the next principle, defect clustering. What we mean about the defect clustering? Defect clustering means 80% of bugs and live in a 24% of code. Find the hotspots. For example, an e-commerce platform finds 76% of all bugs are in checkout at the payment flow. The QA team allocate over half its time to those two areas and catches far more issues. Complex or frequently changed modules attract more defects. Finding one bug in an area usually means more than nearby. Cyclomatic complexity metrics help predict risky modules. Defect history from past releases is powerful guide. Concentrate testing effort. Don't spread it evenly. So we'll go to the next principle. So the fifth principle, the pesticide paradox. What is that? Same test, same result, involve your suit or go blind. A team runs the same 200 and regression test for 6 months. New features keep shipping defects that none of the existing tests were designed to catch. The suits needs growth. Named by the Boris Bezer, borrow from the agriculture pest resistance. A fixed test suit stops finding new types of defects. At new cases after every sprint or release, exploratory testing catches what script test needs. Mutation testing checks if your suit would catches a real bugs. So we'll go to the next principle, which is testing is context dependent. What was that? There is no universal strategy. Know your environment. For an example, testing Peacemaker firmware requires formal proofs and FDA sign-off. Testing a recipe app needs to decide device compatibility and usability checks. Same discipline, completely different playbook. Domain risk and consequences of failure shape everything. Medical software, formal verification, regulatory compliance, and e-commerce, performance, security, cross-browser testing, embedded or automated, hardware in the loop validation, mobile, device fragmentation and network condition simulation. We'll go to the next final testing, which is absence of errors fallacy. No bugs doesn't mean it could solve the right problem. For an example, we'll see the example. A government portal passes every technical test, then 70% of users abandon it because it takes 15 clicks to submit a simple form. Zero defects and still a complete failure. Why? A verification. Did we build it right? Validation. Did we build the right thing? Both matter. User acceptance, testing, validation, a real perfect. Perfect code for the wrong requirement is still a failure. Quality is defined by a user value, not the test report. So these are the 7 principles that we are covered. So the key takeaways, we covered a 7 principle, which is the key values what we have to see. Testing shows presence of defects. It's never absence. Exhaustive testing is impossible. Choose wisely. Test early. The cost of late defects is too high. Defects cluster. Put effort where bugs actually live. Pesticide paradox. Keep involving your test suits. Context matters. No universal approach to risk. Absence of error fallacy. Validate, not just verify. So we'll go to the next topic, which we have informed types of testing. A structured look at the different categories of software testing, what they are, when they are used, and why each one matters in a professional QA strategy. So we know everyone, we know that we need a testing in the QA, we need absolute testing. So what are the testing? For an example, unit testing, integration testing, system testing, acceptance testing, performance testing, and security testing. And we'll go to the next slide. We'll see one by one. And unit testing and integration testing. Testing at the complete level, then testing how components work together. Unit testing. Test individual functions or methods in complete isolation from the rest of the system. Written by the developers, often using TDD. Fast to run, immediate feedback on code changes. Frameworks. Java, .NET, and Python test. Catches logic error early and cheaply. Does not test how components interact. Integration testing. Test how multiple units or modules work together as a combined system. Identifies interface defects between modules. Approach. Big bang, top down, bottom up. Test APIs, database, and service connections. Catches issues unit test cannot. Example, a data mismatch. More complex setup than unit test. These are the integration testings. So we'll go to the next slides. System and acceptance testing. What those are? So system testing. Below everyone, system testing validates the complete integrated application against a specified requirement. It's a black box approach. Tester do not need to know an internal structure. It covers functional correctness and reliability, performance, and security of the entire system as well. We know there are some types of black box, end-to-end QA team and clear UAT. Acceptance testing. What is the acceptance testing? UAT is performed by the end users or business stakeholders to confirm the system meet their real world needs to and business requirements. Connecting back to principle 7, absence of error fallacy. So this is coming to the testings, but we need to do this. We'll go to the next one. Performance and local testing. Performance testing checks how a system behaves under the expected and extreme condition. It's not just about whether the software works. It's about whether it works fast enough for enough users without falling over. So we can able to see load testing, stress testing, and spike testing. We'll go to the next one. Usability and compatibility testing. Usability testing is evaluate how easy and initiative and application is for real users. It connects directly to the principle 7, absence of error fallacy, as earlier we have seen the principles. A technically flow wells system that users find confusing has still failed. 5 users can expose 85% of usability problems. Task-based. Users are given a realistic task to complete without a guidance. Think aloud. Users and narrate their thought as they interact with the product. So, compatibility testing. What is compatibility testing? Compatibility testing verifies that the software works correctly across different environments, browsers, operating system, devices, and screen size and network conditions. So different browsers, Chrome, Firefox, Safari, and Edge, multiple OS version, Windows, Linux, Mac, which means iOS, Android. So the varying screen size and resolutions. We'll go to the next slide, which is revision. So we have covered both of the topics what we have. So now I'm ready for a small MCQ question as a revision, which is we have gone through so far. So we'll able to see for the first question, which is ISTQB principle state that testing can prove defects exist, but cannot prove they are none. So we have now testing shows the presence difference. This is the answer. So the second question, what technique divides input data into groups where every values should produce the small result? It's equivalence partitioning. The third question, the pesticide paradox means that, as we already talk about the principle of this means running the same test repeatedly stop finding a new difference. The fourth question, which type of testing validates the entire integrated system against specified requirements? It's system testing. The last question, a bug-free system that does not meet user need is an example which principle. As we all know, it's absence of errors fallacy. So we'll go to the next slide, which is the final summary. What we have gone through so far. Principle of testing. All we know, the 7 principles which we have covered, and the type of testing and what we have covered so far. So thank you for the patience and everything. And thank you for the timing. Have a great day. Thank you so much.